Good morning, team, and welcome back. I'm Corey, and we're about to get started on day 9 of Advent of Code in Rust. If you missed the previous days, check out my playlist up top for all my solutions. And don't forget to like and subscribe for more videos. Let's get started. Okay, let's get started on day 9. Day 9, Rope Bridge. This rope bridge creaks as you walk along it. You aren't sure how long it is or whether it can even support your weight. It seems to support the elves just fine, though. The bridge spans a gorge which was carved out by the massive river far below you. You step carefully. As you do, the ropes twist and stretch. You decide to distance yourself by modeling rope physics. Maybe you can even figure out where not to step. Consider a rope with a knot on each end. These knots mark the head and the tail of the rope. If the head moves far enough away from the tail is pulled toward the head. Due to nebulous reasoning involving plank lengths, you should be able to model the positions of the knots on a two-dimensional grid. Then, by following a hypothetical series of motions, your puzzle input, for the head, you can determine how the tail will move. Due to the aforementioned plank lengths, the rope must be quite short. In fact, the head and tail must always be touching. Diagonally adjacent and even overlapping both count as touching. Okay, so they can be right next to each other, they can be diagonal from each other, and they can be in the same spot. If the head is ever 2 steps directionally, up, down, left, or right from the tail must also move 1 step in that direction so it remains close enough. Okay, so if there's a gap between a head and a tail, it collapses. Otherwise, if the head and the tail aren't touching and aren't in the same row or column, the tail always moves 1 step diagonally to keep up. Okay, so if they're not right next to each other, they move like just diagonally as much as they can, like in the directions they need to move. You just need to work out where the tail goes as the head follows a series of motions. Assume the head and tail both start at the same position overlapping. For example, this series of motions moves the head right 4 steps, then up 4 steps, then left 3 steps, then down 1 step, and so on. After each step, you'll need to update the position of the tail if the step means the head is no longer adjacent to the tail. Visually, these motions occur as follows. S marks the starting position as a reference point. So you start with them both in the same position, and then you move, and then S marks the starting position. Got it. And then you move, and then you move, and then you see how the tail gets dragged behind it. Oh wow, that diagonal rule does make it get dragged behind it kind of nicely. Okay, after simulating the rope, you can count up all the positions the tail visited at least once. In this diagram, S again means the starting position, which the tail also visited, and the hash marks other positions the tail visited. So you like get the path that the tail took. So there are 13 positions the tail visited at least once. Simulate your complete hypothetical state of motions. How many positions does the tail of the rope visit at least once? Okay. Let's think about how we want to do this. So we can definitely start with parsing the input, which shouldn't be too bad. Oh, well, I guess the first thing that we want to do is we want to make our new cargo thingy. 9 for, say, cargo crate is the word I was looking for. Rope bridge. Okay, there we go. And now let's add it to our cargo workspace. Rope bridge. We're not actually like ever using the cargo workspace and referring to these other crates from each other, but we could. That's kind of why you might want to do a cargo workspace in general, and it keeps the versions in sync nicely. But we're just using it to group them together for the most part. Okay, but all we really know that we definitely want is parsing this. We're gonna parse this into like probably a move enum, and this can just be a number for but we'll get each row as something. Okay, so let's make an example file just to do it. Example input. Paste that in. Okay, so then we'll have let's get rid of this test. Okay, so we will have a enum for direction. That's really what we want. Up, down, left, right. Let's just go ahead and derive at least debug on it. And then let's do enum like head movement, or maybe just movement. It has a dir, which is a direction, and a count, which is a usize. Okay, and then from here, I think we can do like, oh, I might just be lazy and do struct puzzle input is a vec of movements. And then I can do impl puzzle input, do a function parse, input is a string, gets a self, and then from here we can do input.lines. This is what we've done in lots of them. We'll map a movement parse, which we don't have as a method yet, but we will in a minute. And then we will collect that and wrap it in our self. Then the collect knows it'll be a vec, and that should work nicely. Can I get you to just... I can't. I was hoping I could just get it to make me that for me. Impl, movement, we're gonna do our function parse input string goes to a self. Okay, so here we want to do let parts equal input dot split. We're gonna split on the space this time, and then let the direction equal input dot next dot unwrap, and let the count equal input dot next dot unwrap. Except we're not gonna let the dir stay that. We're gonna now say let the dir equal direction parse. And this method doesn't exist, but I can generate it. That was nice. I like being able to generate it. And then here we're just gonna do a match on directory. If it's, we're doing capitals. Direction right, left, goes to direction left, up, goes to direction up, and down, goes to direction down. And then anything else, we panic and say unknown direction. Okay, now we can parse all of this out, and we can just have a test that, I don't know, test parsing. We can at least use it to get the debug output. We can like look at it. Include string. Example input. Oh man, I was so close. Okay, and then let parse equal puzzle input parse the input. Yep. And then let's just debug out parsed first, and we will go from there. Run the test. And oh, we are not compiling. What's going on line 22? Enum. Oh, that's not an enum. That's a struct. Mutable. Oh, parts. Dot next. Oh, and then I also forgot to do self of dir count. Isn't it count? Oh, let count equal count dot parse dot unwrap. Cool. I like doing this variable shadowing where you just do a let by the same name and shadow the old let, and it can be a new type. So we started with a string and then made it a direction, started with a string and made it a usize. Just a nice pattern. Okay. Test parsing. Oh, it can't be debugged. I thought I put the debug on it, but I might not have put the debug everywhere. I definitely did not put the debug everywhere. Derive debug. Throw it on that. Okay, there we go. Yay. Okay. Right 4, up 4, left 3. Right 4, up 4, left 3. Down 1, right 4. Yeah, okay. That looks like it's parsing correctly, and now we actually get to think about this problem a little bit. So I definitely can just keep track. Okay, I think I'm just gonna do this relatively naively. So the puzzle input has a vec of movements. Yeah, okay, let's just do function part 1. Let's just get started, and I think we're gonna do this kind of naively, but that's totally fine. So in general, what are we actually giving? What's our answer at the end of the day? How many positions does the tail of rope visit? Oh, okay. So it's a U size. Um, let's also make a struct for a coordinate that is X as a U size and Y as a U size. We can also just go ahead and derive debug for it. I think we're just gonna want that in general. But okay, let's get this set up. Why aren't, oh, because you don't have semicolons there. Yep, that's unused, totally fine. Let's just do test example part 1. Part 1, there we go. Let answer equal puzzle parsed. So what am I gonna want to do? Oh, actually, I'm not gonna, I'm probably just gonna want to do part 1 of input. Yeah. And then this is gonna, we'll just change this to an assert equals that the answer is 13. Right now, this will just panic on not yet implemented. Perfect. Okay, so now we can do open let input equal puzzle input parse the input. Yep, I could have just left it. Okay, so now we have our input and let mutable head, which is a coordinate equal coordinate 0, 0. Let's just actually do impl default for coordinate. And actually, let's just, what do you implement? The missing ones, perfect. That would be cool if that worked. Then I could have just derived default. But there we go. Let's do that. Wait. What are you upset about there? Unused imports. Wow. Okay, there we go. Yeah. Nothing is ever constructed. I know. Let's go ahead and do public there so that it knows some of these things are used. And then this can just be default. Default, that's really not much shorter, but that's okay. So we have head and tail. And then we just wanted to like go for M in input.movements. We're just gonna go through oh dot 0 because I didn't name it. Okay, so we want to move the head. Oh, and I guess I got to do it. So then I do for So we can just do let. Actually, so for this is a movement of direction and count. Yep. So for underscore in count, so we just gotta loop and do this count times. Usize is not an iterator. Oh yeah. Zero. So we need to do a range. Okay, so now I want to just update the head 1 in this direction. So impl coordinate, a function called move in a direction. It takes a reference to self and a direction, and it returns a new self. And we match on direction and fill the match arms. Perfect. If it's up, we make a self where x is self.x and y is self.y plus 1. If we were to go down, it's the same with a -1. Left is going to be x -1. And y is not going to move in that case. Missed my s. Take this one for the right as well with a plus. Oops, with a plus, with a plus. There we go. Okay. Then that covers all of the directions there. And so back up to where my part, or down, I guess. Yep, down. There we go. Here I can do head equals head dot move in direction. And now this is where we want to update the tail to follow along. So if the head dot distance to the tail is greater than 1, because if it's just right next to it, that's fine, and right next to it could even be diagonal. That's what the distance is gonna say. If it's greater than 1, move tail to follow. That isn't implemented yet, but let's implement this distance to method first. So I think what I want to do, distance 2 is interesting because it's not the Manhattan distance. I think I want the maximum. Well, it really doesn't matter too much if I'm just comparing with 1, but I think I'm gonna do the, okay, so I think I want let x diff equals self dot x minus tail dot x. X is a U size, so it is not, it'll overflow. So if self.x is greater than tail.x, probably is a slightly better way to do this. Else tail.x minus self.x. Okay, and then x, let's just do y diff because I'm gonna want it. If self.y is greater than tail.y, self.y minus tail.y, else tail.y minus self.y. Okay, and then x diff dot max with y diff. U size, oops. Awesome, returns a U size. It's not properly closed. Oh, it's not. Cool. Okay, so distance 2, oh, it doesn't need an actual tail. It can just take a reference to it. reference to a tail. Move in direction also can just take a ref. Wow, I keep doing that. It can just take a reference. If I tell it, it can just take a reference. Okay. Okay, so now I need to do, if the distance is greater than 1, I need to move in, I need to go figure out which direction to go, where diagonal is a direction. Well, that just means if I need to move up and right. Oh, okay. So, okay. This isn't too bad. I could loop over all the directions and just move in any direction I need to move. If I need to move up, I move up. If I need to move. Okay, so that's not awful. Let's do that. So is this on coordinate? Let's just write it out first. For D in direction all. And then for the direction, if a tail dot well, I need to well, that's fair. Tail dot move needs to move forwards. Not sure I love this, but that's okay. Head and direction. That can be a reference to direction, because then we're gonna do tail equals tail dot move in direction reference to D, because that's the direction I'm dealing with right now. Generate the all function. This is a direction of for array. Self up, self down, self right, self left. I'm not sure if I like it better with self or if I had typed out direction, but I don't know. I already did this. Okay, so now I implemented all. I still need to implement needs to move in direction. Okay, so this is, we want to match on D if this is direction down. So do I need to move down? I need to move down if head.y is greater than self.y. Direction up if head.y is less than self.y. And direction right is if head.x is greater than self.x. And direction left is if head.x is less than self.x. Okay. That should be all of the directions there. Move in direction I already have covered. Sure, replace with a for each loop. Why? What else do you want? Nothing? There's some errors here though. Oh. Okay, actually, so let's just undo a second. I like the for each better. Oh, oops. Wait, edit, redo. Edit, redo. Okay, well, uh-oh. Replace with, oh my gosh. Okay, so did I just, oh man, I messed up. I got rid of this whole function. That's unfortunate. Fill in the match arms. Okay, up. If head.y is greater than self.y. Head.y is less than self.y. Head.x is less than self.x. And head.x is greater than self.x. equals. Okay, perfect. Okay, for direction in D, if it needs to move it. Yeah, that'll handle going diagonal if I need to. Okay, so then let a mutable tail visited is a hash set of coordinates equals default. Uh, no matter what here, I do tails visited dot ins dot push uh dot push tail. I thought that was gonna work. So what is it not push? Insert add. I'm confused. What can I do with a Rust hash then? Rust hash set insert. Yeah. Insert. Doesn't satisfy. Oh, can I not use chord because it doesn't do hash and equals? Partial equals. Oh, and equals. Okay. There we go. Um, old tail equals tail. Um, tail dot clone. I need to make coordinate implement clone. I could also just make it implement copy. Old tail. Oh wait, now I actually just don't need that at all because now it just knows that it can copy it there. Oh, that's nice. Yeah. Okay. So is this now just tails visited dot length? And then does that pass the test? That's the real answer. No, we get 16 and the right answer is 13. Okay, so let's debug out tails visited here. And let's just see what we see. Okay, so we start at okay, where do we start? We start at 0, 0, and then we go to uh x of 1 and y of 0. Yep. And then we go to interesting. Oh, well, it also might just not be ordered how I want it to be ordered. Because who knows how it's ordered. Okay, that's fair. Okay, so let's just look through it and see if there's an obvious bug, I guess, and then we'll keep debugging harder. I guess the answer is here that we should just do, never mind. Never mind, let's just do this. Actually, what if that doesn't matter. Since I made a things copy, it would be fine if I just if I didn't take in things by reference, and then I pass them in instead. They just get copied, which is like almost better probably for me. Yeah, see, that's what I was a little bit curious about. Um, but now it's mad at me because use of value dir. Okay, so I guess it was better too. have this be a reference, and there was no reason to change it. So let's go and change that back. Okay, so we're still looking for an obvious bug here. Okay, so for movements, which are direction and count, we loop for the count. For the head, we just say move in the direction. And then if the distance from the head to the tail is greater than or equal to 1, no, greater than 1, because it doesn't move when they are right next to each other. But if there's any gap at all, it'll move, because that's what we show up here. It follows the gap. And if there's too big of a gap, it moves in both directions to get to where it needs to go. Yep. Yep. Okay. Yep. Is greater than 1, because here we would get like 2. Yeah, so if there's ever a gap of 2 in any direction. 1, 2. There's only a gap of 1 here, but there's 1, 2. And distance 2. Yep. Yep. X diff minus Y diff. There's got to be just like a self dot Y dot abs diff. Yeah. Uh tail dot Y. We watch this. It would be nice to have a clippy for that. This would be a nice clippy. Self dot X dot abs diff or tail dot X. Oh, that doesn't actually tell me what it's doing. It just gives me a fun implementation. Okay. I'm pretty sure. Oh, computes the absolute difference between. So yeah, that definitely looks like what I want. Cool. Much nicer. And then we do the max, but that looks right. Needs to move direction if head Y greater than self Y, down if yep, left if we need to move left if the head is less than X, and we need to move right if the head is greater than X. Yep. And that is how we use it. Tail needs to move towards. Yep. Yep. Then we do moving in that direction. And then we debug out the tail and we insert it. Okay, let's try this and see what the direction is. See where we mess up. Okay. So we start with our tail at 0, 0, and then the first move is nothing because the tail doesn't move. And then the next tail is 1, 0. And then it stays at 1, 0 for a while. Okay. And let's debug out a little bit more just to make sure that what we're looking at here is what we think we're looking at. So let's do head, tail, and probably also direction, count, and I. Reference to dir. Okay, there we go. Direction should also just be copy though. Okay. Awesome. Let's run the debug again. Let's look at this. Oops. Clone is not implemented for direction. Oh, that's funny. Direction. Yes, it's clone as well. I think it should imply it that direction too, but I guess it makes sense that it doesn't. Okay, starting from the top. Whoa. Why is the head all the way at 0, 2? Where am I doing my debug? I didn't think. Oh, I am in there. Okay. Um, I guess I just want to put it after every move that happens. Oh yeah, because I don't need to print it out in this loop. Okay, yeah, that actually makes more sense. Let's do it there. Oh, I thought I was just gonna get that test to replay from where I was. That would have been really cool. Okay. Let's see. We do 1, 0, the head 0. We're moving right on a count of 4. We've done 0. This is our first loop. We're 1 behind it. Yep, that's right. We're still 1 behind it, following it. 1 behind it, following it. Head moves up 1. This is not gonna move, is that right? Yep. And then the head's gonna move up again. Yep. And this time it goes to, yeah, it follows it. It goes to where it used to be 4, 1 behind it. Yep. And then it follows it up. Okay. And then the head is going left. At first, we don't move. And then we follow behind it. Okay, so what's going on? This seems right to me. I don't see where this is doing things. There are 13 positions the tail visited at least once. Simulate your complete hypothetical series of motions. How many positions do the head and tail of the rope visit? Oh, wait. How many positions does the tail visit at least once? Yeah. I thought it said head and tail, and then I was gonna be even more confused, I guess, because 13 is lower than what I'm getting. Um. Oh, okay. Well, then H covers T here at the end. Oh, okay. That's an interesting edge case. I'm not sure if I'm covering. T covers S. That one's not as exciting. Okay, so when we're going right at the end, yep. When we're going right at the end, after the first time, the head should cover the tail. Okay, so right before we go right. It would be cooler if somehow these debugs were grouped together. I'm not sure how I would even make that happen. Yes, maybe I do. Let's try. Let's try. Can I do before and then after? And will that just do what I need it to? I hope so. Okay. Nope, they just got. Oh wait, no, before, after. Yeah, no, that's the right order. Okay, cool. So that was the first one. Okay, so before we start moving to the right, the head is at 0, 2, and the tail is at 1, 2. That's not what we have up here, right? Because oh no, head is at 0, 2. Um, Tail is at 1, 2. Yep, that is what that says. And then we went right the first time. Oh yeah, and we get 1, 2, 1, 2. And then we moved right the second time, and we got head at 2, 2, tail at 1, 2. Yep. Yeah. The ending is right. So what's happening wrong here? Yeah, okay, so which spots do I think were visited that were not? Can I print out a grid like this? I could, probably. Um, let's try that real quick. Where would I want that to be on? What could I not much actually. Just I have my cache set, but that doesn't have a so function print visited takes in visited hash set of coordinates. Doesn't do anything. Okay, so then let the so first I want to print out, so I need to loop for my y's, loop for y in 0 dot dot I guess I just don't know what the max or min could be. Oh man, I don't really want to do it that way. Okay, let's just do it manually for some debugging. So 0 0 um okay, well, could I just do we ever does it ever give me? No, but I could do the okay, so let correct equal a hash set. Now let's just make it an array of coordinates starting at x0. What if I actually just do these as tuples of 0 0? There we go. And then 1 0 2 0 3 0 3 0, and then 4 1, and then 4 2. Nope. 4 2. 4 2. And then 3 2. 3 2. That's what that's what that is. And then 2 2 0 0 1 2. So then 1 2. Um and then from 1 2 we go to 0 1 2 3 3 0 1 2 3 3 3. From 3 3 we go to 4 3. And then from 4 3 we go up, so there's 0 1 2 2 4, and then this is 3 4. Assert equals correct length is 13, right? Because if not, then that is just not the correct set, and that would be hilarious because I would have typed it wrong. On line 164 is down there. Okay, awesome. So let's do 4. Let's make sure that this works. Oh, well, I don't have access to the hash set here. I'm gonna have this return the whole thing instead of the that was visited, at least for right now. Then the answer length. Assert that answer includes that contains C. Doesn't contain C. This needs to be print lined where that needs to be debug printed because that's what it needs to. That's the macro print line. Uh, unless this is actually just a format string, it's probably just a format string. That makes more sense. Contains, this is going to be a reference. No? Oh, sure. X comma Y, this is actually going to be a coordinate X, Y. Oh yeah, could just do that and that. Dang it. Not that big of a deal, but like, let C equals that. Okay. Assert doesn't contain C. This is there. It's gonna contain all of these though. Can't leak private data. Quote isn't public. Okay, that's easy to fix though. You can be public. At least to the crate. Oh, I just had would have had to make the other thing public too. That's fair. Okay, so it contains all of those ones. Awesome. What are the extra ones? So open let correct be a hash set of correct dot into okay, so then I want to do debug the answer dot difference with correct. What does it want? Oh, it's this whole, it's the wrong thing. Dot iter dot map x comma y coordinate x comma y. That ends the map. Then we collect it. Consider dereferencing the borrow. Can I just tell it that it's a borrow to x and a borrow to y and do it on the other side? Dang it, it doesn't work that way this time because now I think I gotta do that. And we gotta do that, which is just a little silly, but that's fine if it works. Different must be used. Oh, okay. Let diff vec equals the answer dot difference reference to correct. And then diff. Oh wait, no. Is this gonna return? Oh, I can collect it to a hash set. That works. Difference 2, 3, 0, 1, 2, 0, 1, 2, 3. Yeah, okay, so when do I hit 2, 3? When does the tail hit 2, 3? When does the tail hit 2, 3? I could just only print out that or something. Tail at 2, 4, tail at 2, 4, tail at 3, 4. Yeah, might have been the best way to do this. Wait a sec, I didn't see that. If tail equals coordinate x2 y3 debug this one. What? Struct literal. Oh, surround the struct literal in parentheses. Oh, I was just missing that. Oh no, it does want the parentheses. Interesting. Okay. Was that enough? Maybe. Nope, I didn't see this one ever. I'm not doing the this doesn't want to happen here. It wants to happen after all the directions to do the diagonals right. I wasn't doing diagonals right. I'm pretty confident in that one. Oh. Oh, now it's a unintentional. Now it's that I'm not using my eye. Doesn't contain coordinate 0, 0. Okay, that's fair. I'm glad I left that in then. Just because it would have been annoying to debug that one. Tails visited dot insert tail. Tail. There we go. Awesome. Okay. Now let's do my input. This one took a little longer than expected, but making progress now. And let's see if this works for my input. I'm going to get rid of most of this, but I'm going to copy all of it. Test my input. We don't know all of this. And length is 13 is what we're going to go with. Not going to be right. And ooh, attempted to subtract with overflow. Okay, line 80. What are we doing at line 80? Ooh. Oh yeah, because we did do everything with U sizes. I sizes aren't a thing, are they? Oh, they are. Oh, cool. Okay. Substitute. So what do I want to do? What do I want to do? Every line substitute a U size for I size. Yep, and then global. Yep, everything. Oh no. But why is there any U sizes left? Like why are we still why do we still have some type issues? U size. Oh, abs diff. Oh, yeah, okay, that's fair. This one does want to return a U size. Okay, there we go. Now we can use negative numbers. 6498. 6498. Yes, okay. 64498. Awesome. Run test. Okay, let's commit that. Day 9, part 1. Commit anyway. Okay, and part 2. A rope snaps. Suddenly the river is getting a lot closer than you remember. The bridge is still there, but some of the ropes that broke are now whipping towards you as you fall through the air. The ropes are moving too quickly to grab. You only have a few seconds to choose how to arc your back and come to avoid being hit. Fortunately, the simulation can be expanded to support longer ropes. Rather than 2 knots, you must now simulate a rope consisting of 10 knots. 1 knot is still the head of the rope and moves according to the series of motions. Each knot further down the rope follows the knot in front of it using the same rules as before. Using the same series of motions as the above example, but with the knots marked head through 9, the motions now occur as. Okay, so you just move based on the one right before you. And besides that, it's the same thing. Okay. And then now you need to keep track of the positions. The new tail 9 visits. In this example, the tail never moves, so it only visits one position. However, be careful. More types of motion are possible than before, so you might want to visually compare your simulated rope to the one above. Here's a larger example. These motions occur as follows. Individual steps not shown. So we just like show all of the ones that get marked, and we get 36 in that example. Okay, so we need to extend this to lots of more ropes. So I think what we're gonna do is we're gonna figure out how to extend our existing thing to an array of tails, and then we will just change the size of the array or something for part 2. Okay, so we committed, right? Okay, awesome. So part 1, so this is like rope like rope course or something. And rope course. Oops. Rope course. 2. Okay, awesome. When I do generics for part 1 and part 2, I like naming it something else. So tail count is a U size. And okay, so then let mutable tails equal it's a coordinate array of tail count. Default still. What? Why can't I do that? I was pretty sure I would. Oh, can I think I know what to do though. Where an array of nothing and tail count an array of, let's just make it the thing I want, right? Because why not? Coordinate implements default. And this will be for most tail counts, this will be true up to some number, but I think this will be perfect for what I want to do. Okay, tails at 0. So let's just we will say that there always has to be a tail. Panic assert equals nope, assert that tail count is greater than 0, must have at least one tail. I don't think I can easily put this in the type system, so we're just going to do this at runtime. That makes this 0 safe, because I know we're going to have a tail. Okay, so then update the tails to follow along. So now what we need to do is for tail index, in 0 dot dot tail length, we just have the constant already. Let current tail equals tails at tail index. Let head equal, if tail index equals 0, then it's head, else it's tails at tail index -1. I maybe could just put the head in the array and stuff. Right now we're just gonna keep it out because that's what we had for before. Okay, so now we want to do like if head dot distance to current tail is greater than 1. We want to do this loop, and then if current tail dot needs to move towards head, yep. So then this is where we're gonna need to do something different. We're gonna need to do this. Tails at tails index equal current tail. And then this is just tails at tail index. I might actually get rid of current tails. Tails at tail index because the variable when I'm dealing with updating later on, it seems like I could accidentally be using the wrong thing when I don't mean to. So I'm just gonna inline it. Okay, awesome. Delete parentheses, it doesn't like that. Okay. I think I just moved this along. Or I just copied this along, and I think this should work the same. Okay, so what is erroring here? Canton 4. Oh, okay. Okay, so they both gave the wrong answer. Oh, wait. Running 2 tests. 2 failed. Yeah, okay. There's the first answer, there's the second answer. The diff was 3, 1. Okay, so that didn't work. Let's bring back the version. Uh-oh. There we go. That's actually what I wanted down here. Oops. Current tail. Current tail. I'm actually not going to do the same thing that I did before because now I just don't feel like it. I should not keep just going back and stuff. Not the best way to do this, but okay. Once you've moved all the directions, then you count the things the tails visited. Head is this, current tail move in the direction. If current, this actually, that is a bug though. This can't be current tail because we are moving it in this loop. There we go. Okay, so that actually is a pretty good reason just to not have current tail be a thing. It's exactly what I was saying. Wasn't my favorite. Okay. Head, and I don't actually know. Oh wait, head equals moving in head direction. Yeah. Okay, and then in the this here, now we're moving the tails, and we have a new thing that we call head because it's whatever is the head of the last tail. But I could rename this. Rename symbol to current head. It's whatever you're following along, but current head works. So if this one needs to move towards current head, yep, we do that. Okay, that all seems right to me, though. So for each movement, Yeah, so we move in the direction and then we just update the tails if we need to. If the distance from current head, I wonder, oh, I wonder if this one was using it. Okay, let's see if this is better. Okay, so it's just this one place though. 3-1 is visited now, but was not before. Oh, wait. I'm just doing the wrong thing. I'm doing 2. 2 isn't what I want. There's only one tail. I have special case. I did it the other way. How many tails? Yeah, that's right. Okay, so this is right. Awesome. Um, let's try this again for my input, for the example input. Test example 2 tail part 2. Uh, test example 2 tail, I guess is, no, it's a 9 tail. Example, but this we said that it should just be 1. Oh, that was easy. And by easy I mean sad. That didn't work right. Left is 16, right is 1. So we got 16 here for rope's course with 9 tails. Why is that the case? This gives 13, yeah, when you do it with 1. Okay. But when I do it with 9 tails, we get 16. Okay. That's interesting. Why is that happening? Head equals move in direction. Oh yeah, so I do have to make sure not to overwrite head, but I don't think I'm doing that. Especially now that I'm using current head. Hmm. What's even more annoying is it worked for 1 tail. And this is 9 tails, right? Rather than 2 knots, you ropes a rope consisting of 10 knots, so 9 tails. And the thing with this is that it doesn't think, oh, but when we count how many places the tail touched, we're just counting the last tail. That's what I was missing. The true tail. If tail index equals tail count minus 1, tails visited, because tails visited is actually gonna be last tail visited. And now if we do this, awesome. Okay, so the last tail only visited 1 if in this case, but I think we get another example. Here's a larger example. Larger example. Larger example. Larger example. Okay, and what's the answer for this larger example? 36. Awesome. Okay, and let's do this on my input. my input, don't think it's going to be 36. 2531. There we go, day 9. Let's plug that in real quick. 2531. And let's go and run all of our tests. And 5 passed. Awesome. Okay, make our commit. Day 9, part 2. Awesome. And we will push those up. And there we go. That will officially wrap up day 9 of Advent of Code in Rust. Thank you for joining me. I hope you enjoyed these videos. I'm having fun making them. If you liked it, give me a like and a subscribe so you know when the next videos come out. Day 10 will come at you real soon. Thanks. Bye.